We're going to determine if the following functions are even or odd here in example 3. Let's do a reference equation. We're going to do this algebraically. So the reference is a comma b, and that'll be the absolute value of a is equal to negative 3y. The absolute value of a is just a. Remember, a is positive and b is positive. And that'll be, oops, sorry, I should have made that a b there. And that'll be negative 3b. So here's our reference equation right there. To determine if the functions are even or odd, let's do the even one first. So the even test is just the y-axis test. It's the same one. So it's negative a comma b. Let's see what happens here when we figure this one out. So we've got negative a going in for this one, for the x, equal to negative 3 times b. The absolute value of negative a is just a, and we've got negative 3b. That's the same as our reference, so we can conclude that yes, this one is even. So let's check it out if it's odd. To figure out if a function's odd, simply test for symmetry about the origin. Same thing, just another word meaning symmetry about the origin. So what we're going to do is we're going to do the absolute value of negative a is equal to negative 3 times the opposite of b. The absolute value of negative a is a, and then a positive, or negative times a negative is a positive, so it's 3b. Notice how this is not the reference, and there's nothing we can do algebraically, so we would say no. The answer to this question, determine if the following functions are even or odd, is you would really want to write this, I suppose. So the best answer would be it's even. The next one, our reference, is going to be b is equal to 1 over 4a to the 7th. For determine if a function's even, we'll use that y-axis test, so we'll go negative a, b. Plug that right back in, so we've got b is equal to 1 over 4 times the opposite of a to the 7th. Remember, when we raise something to an odd power like that, it's going to be negative, so we'll have negative 4a to the 7th. This does not look like the reference, and there's nothing we can do to make it look like the reference. So the answer here will be no, it's not even. And for the odd function, we're simply going to use the exact same test we did for the origin. That's what odd means. Odd means that the function has symmetry about the origin. What we'll do now is we'll do the opposite of b, and for the f of x, or the y, 1 over 4, then we've got the opposite of a to the 7th. So this is the opposite of b over, and then that's going to be negative, so we'll have negative 4a to the 7th. We'll multiply or divide by negative 1 on each side, and b will be 1 over 4a to the 7th. So this one's yes. This function does have symmetry about the origin. Yes, it does have an odd exponent, but that's not the thing that makes it odd. Lots of functions have odd exponents and are not odd functions. So we would conclude that this function is odd, and that would be your final answer.